Hi everyone, welcome to this video for JC1 H1 Mathematics. In this video, we're going to go through Pop Quiz Chapter 7 on the topic of integration techniques. And in this video, as you go through and review your Pop Quiz, hopefully you can reflect and pick up some of the good practices that you did and also that we'll be highlighting here. And at the same time, let's look at some common errors. And hopefully, if you make these errors, make sure next time you don't repeat these errors. Okay. Now, the thing about integration technique is that this topic is a very skill-based topic. So what you need to do to master this topic well is nothing but to just practice and to know roughly what strategies to do in order to integrate well. Okay, so you can make, after this, you can make use of your section C, right, and to compare your answers with the updated solutions as well as your previous papers that you can find on the website. Okay, so without further ado, let us start to look at question 1. So question 1, right, technically speaking, we have learned how to integrate this ax plus b bracket n dx. Okay, so the thing about this is, if you observe, right, this is the top component. However, that at the bottom there is actually a 2x for us to divide. Okay, so because of this, right, what we need to do is we cannot be using this particular formula. Instead, we will need to try to simplify with this in mind. So how do we simplify with this in mind? Okay, with these 2x in mind, is that we need to break this up into smaller fractions, right? Break this fraction up to smaller parts and to simplify one by one. So how do we do that? Okay, so let's take a look. So over here we have a square, right? So this square over here, how do we open this up? And in order for us to break down, we have to open by expansion. And how do we expand? A square, so a square minus 2ab, so minus 2ab, so 2 times 3 times 5, 30x. Okay, and then 8 square will be 80, no, 3 square will be 9. Okay, then plus 5x square, so 5 square, 25x square. Okay, so all these together. So this is the important one. So divided by 2x dx. Okay, now in order to make things easier, I'm going to take out this constant multiple, right? So this is actually half divided by 2, right? So this is actually half, and I will put the half outside. Okay, so now next thing, I will need to divide 1 by 1. So this step over here, right, technically is a filler step that you don't really need to write lah. So I write in a lighter ink so that we can see. So 9 over x minus 30x over x plus 25x squared over x dx. Right, so this filler step, up to you. If you're comfortable, you can skip this step. If you're not comfortable, you can continue to write this step. Okay, so now let us take a look at how do we analyze this. Okay, so we have 9 over x, which I will leave there, or if you want, you can put 9x power negative 1. Okay, now this one over here, we have 30x and x, so we can cancel these two terms. Okay, we can cancel these two terms. So this will be just minus 30. And last but not least, we have the x squared divided by x. So this would be just plus 25x dx. Okay, next, over here, half on the outside. I think we are ready to integrate. We are already at this point, ready to integrate. So first, x power negative 1, right? So we can make use of the power rule. Okay, we can make use of the power rule. The power rule, namely the power n lah, except for n equals to negative 1. So if n is equals to, if the power is negative 1, what do? We use ln. So we will integrate this to ln 9 ln x. Okay, or you can say 9 over x, right? When you integrate this, it should be 9 ln x also can. Okay, so this one, the power is the one that you need to take note. Power negative 1 or 9 over x means that we will integrate to ln x. Okay, so this one is something that you need to remember. Okay, in the lecture we've also explored, let's say if you integrate -1 plus 1 divided by new power. This one cannot write, so we cannot use the power rule to divide, to integrate. Okay, so something for us to take note. Next, 30 is a constant. So we have 30 x power 0 plus 1 over 1. So it's just 30x. Okay, plus now 25x power plus 1 divided by new power. Like that. Okay, so we can keep our answer like this plus c. If we want, we should be simplifying or expanding this to individual terms. So 9 over 2 minus 15 plus 25x squared over 4 plus c. So this is the end of question 1. Okay, so let's continue to look at number B, right? Part B. Part B over here, right now, you notice this is 5 over square root of 2 minus x, right? And if you compare between part A and part B, right, the form is a little bit different. For part A, the square is above, and we actually can expand and simplify. For part B, right, over here, we cannot expand and simplify. And this thing already is nested within a power itself. And the power is actually power negative half. And furthermore, there is nothing on top for us to simplify. Right? So we can actually rewrite this into this power form directly. Okay, so how do we do so? So we can write this as, right, 5 bracket 2 minus x. This is power. Now, denominator, power negative. Then square root means power half. Okay, so total will be power negative half, as we've seen in differentiation. Next, after we express this in this power form over here, so what will be the result? Now, bring the 5 out. So what will be the result would be 2 minus x, right? Power plus 1. So half plus 1 is half divided by the new power. And you remember when you do chain rule, you need to multiply with the negative 1. So reverse chain rule means divide by the negative 1 over here. Okay, you differentiate this content to get the negative 1. So we need to differentiate this, so we need to divide by the negative 1 as well from here. Then plus c. Okay, so altogether, fixing this, okay, keep, change, flip. So this would become 10. Okay, and then negative 10, right? Then I square root 2 minus x, okay, plus c. So this is up tidied nicely for part B. So once again, um, you need to identify the form. So this form over here, there is something to cancel at the bottom. So what we need to do, expand, simplify by cancelling. Part B over here, the bracket is at the bottom. So brackets at the bottom, we can't really expand and simplify and separate the fraction. So we can only rely on rewriting this into a power form and to use the integration of this over here, where this one over here, the result is going to be ax plus b power n plus 1 divided by new power and then divided by the a. Okay, divided by the differentiated content. Okay, then plus c. Okay, so this is how the formula for the power rule works. Alright, so let's moving on to question 2. We are finding the exact value of this integral in the form of a ln b, where a and b are exact constants to be determined. So what we are looking for, we are going to look for exact value. So can we use our calculator to evaluate this straight away? The short answer is no, right? Long answer is yes to check whether is it correct or not lah, but short answer is really no. Okay, so now, so why do like, in order to look for exact constants, right, we just need to be able to use the technique to, or apply the technique to integrate this. Otherwise, by just pumping the whole thing into the calculator, right, doesn't really apply any technique, right? So yeah, so this is actually a skill that we also need to know. Okay, but of course, let's say if there's no mention of any exact constants, or if there's no if they don't need it in a certain form, they just say evaluate this, and then it's just 1 mark, then of course we can use our calculator to evaluate. Okay, now then the next thing to take note is, now how do we integrate this one over here? Now let's study a little bit of this. Now here, right, it will be 4 over 2 plus 3x only. Let's take a look at the power of this component over here, right? Is there anything for us to split the fraction? We cannot split the fraction. There's nothing for us to expand either, right? So let's take a look at this power over here. This power of this whole thing is actually power -1. Okay, so if it's power -1, we actually integrate this whole thing to ln. Okay, why? Because when we differentiate ln, it's actually 1 over x, or 1 over ax plus b. Okay, when we differentiate ln. Okay, now only when the power is not -1, and we can only when the power is not -1, we will apply the rule for the power. Okay, the power rule, where you get power plus 1 divided by power plus 1 and the a. Okay, so but then for this one over here, right, this power is -1, 1 over x plus b, right? The denominator power 1, or this one, the whole thing, if you convert, is power -1. And because of this, right, we will have to integrate to ln. Those is something that we need to distinguish. It's not always where you have the denominator like this, right, will always integrate to ln. Okay, it is only when the denominator power 1, or when you convert it becomes power -1, then only you integrate to ln. So must pay attention. Okay, you have to distinguish between this. One more thing also, let's say if we change the question to just this, just a square, then this will be back to this. Okay, if it's 4 over 2 plus 3x, it will be here. 4 over square root of 2 plus 3x would be there. 4 over 2 plus 3x, right, power 3 over 2, right, is also under the first case. Okay, it is only this one where we'll go to the second case, which is to integrate to ln. Okay, so let us do this now. So now we will integrate from 1 to 2. Okay, the expression of 4 over 2 plus 3x dx. Okay, so first I will bring the 4 out because 4 is a constant, so I'll leave it there. Now integrating this, right, is to integrate to a ln function. I'm going to copy and paste the original expression divided by this one, divided by the a. Where is the a? The a is actually 3. Okay, because of chain rule, reverse chain rule, I will need to divide by the a. Okay, so I will get this expression. Okay, next, this 3 over here is a constant multiple, scalar multiple. I'll bring the 3 out as well, so I will get 4 over 3, right? Then I will have ln of, now I'm going to substitute 2 first, then substitute 1. Okay, now why is this so? Is because of the result, the following result. Okay, so if we can integrate this function to a function over here, right, this means that if we want to have a definite integral, right, what we have over here is from fx, we will integrate to the expression over here, and we are going to sub in the value on top first. Okay, sub in the value on top first, minus subbing in the value below. Okay, so this is something that we'll need to take note lah. Okay, when we do the definite integral, so it's b first, sub in b first, then we sub in the a. Okay, right, so subbing in the 2 first, so 2 plus 3 times 2, so 2 plus 3 times 2, this is ln 7. Okay, then subbing in the 1, we'll get ln 5, like this. Okay, oh sorry, this is ln 8. First one is ln 8. Okay, so next, this one would be 4 over 3 of ln 8 over 5. Okay, 4 over 3, 8 ln 5. So now, then can double check. This is in the form of A ln B, right? So this is in the form lah. We already made it to this form. Okay, so you can see that actually all these problems for integration technique is not difficult. Okay, it's a matter of just pattern recognition, right? If n is not -1, if the power is not -1, use the power rule. If the power is -1 or it's just 1 over that thing power 1, right? If it's like this form or this form, then we integrate to ln, right? If it's definite integral, then we do this. So it's pretty straightforward, right? So nothing much to really struggle, right? It's a matter of just pattern recognition and just do it. Okay, so that's for question 2. Okay, so question 3 is the one where it's a little bit difficult. Okay, because question 3, right, is a problem of integration as a reverse process of differentiation. Okay, so let me give you an illustration over here. So first, right, we have a function over here. So when we differentiate, we will get the derivative like this, right? Then the reverse process is if you have the derivative, or we have another function over here, when we integrate back, we can integrate directly back to the original function. Okay, so this is the idea that we will be using in this question. Okay, so part 1, let's differentiate this function e to the power of square root x. Okay, so what I'll do is, let me write this down as e to the power of x power half. Okay, something like this. Okay, so for this one over here, now the one I will show here, this will be the first method. Okay, so if you're comfortable with the first method, then you, after you do your correction, you proceed on, you just fast forward a bit. If not, then you just wait for the second method. All right, so first method, right, is the shortcut method for chain rule, right? Because, right, if you notice, we have two layers over here. We have the outer layer of e, and we have the inner layer of x power half. Okay, so what we're going to do, okay, so one more time, let me draw this one more time. So we have the outer layer of the e, and we have the inner layer of the x half. Okay, so the short way of differentiation, right, is we will integrate, we'll differentiate outside to inside. Okay, so what do we integrate first? We are going to integrate the e first. So integrating e will give us just e, and we'll copy whatever function that we have inside over here. Okay, then the next step is we are going to differentiate the function inside. So how do we differentiate the function inside? Now x power half means that this just a power bring down, power minus 1, like this. Okay, so if you can recognize, right, this one over here, this is your dy du. This one over here is your du dx. Or let's say if you want to put in the notation, this is f. Sorry, let's say if this is okay, something like that. Okay, so now so let's rearrange. So this one will be e x power half, then 1 over 2 square root of x, like that, correct? So we can mash this all into one function. So it will be e to square root of x on top over 2 square root of x, like that. Okay, so this one on top, this half, this 1 over 2, and then this x power negative half will be down to the denominator. Okay, so this is method 1. Okay, so let's look at method 2. So method 2, right, is first we are going to let y. okay, equals to e to the power of square root of x. So this will be the slower method lah, but slower but the steady method, slow but steady. Okay, then right, because of this function on the inside, okay, so I'm going to let, okay, and let u to be this function x square root, okay, which is x to the power of half. Okay, so I'm using the u method lah, okay, to substitute back in. Okay, so what I'll do first is the first one. Now, then I'll look for dy, no, sorry, this one will be y equals to e power of u, like that. So it's to replace the root x, right, with u. Then now this one will be easy to differentiate already. Okay, so how do we do this? So dy dx would be equals to also e power u, and then over here du dx, okay, would be half x power negative half. Okay, sorry, this one I got an error. It's not dy dx, it's dy du. Okay, dy du over here. Okay, so this one, let me change color. Okay, like that. Okay, so now putting everything together using the chain rule. So dy dx would be equals to dy du multiplied with du dx. Okay, so dy du is e power u, du dx would be half x power negative half. And replacing the u, okay, replacing this u back to e to the power of square root of x, like this. Okay, so we'll get this expression over here. And now can you see that these two expressions are the same? Okay, can you see that these two expressions are the same? Right, so obviously method 2 is the longer method lah. Okay, if you need to set up your dy du and du dx using your chain rule. Okay, so this one over here, chain rule. Okay, so if possible, please save time, right? Please learn how to save time, okay, by looking this at layers, and we'll differentiate by layers. Okay, if really cannot, right, then no worries, you still can do dy du and du dx chain rule. Okay, so with this over here, we will still get the same answer, e power root x over 2 root x, like that. Okay, so this would be method 2. Now, for the sake of question 2, right, I'm going to remove method for the sake of part 2, I'm going to remove method 2, okay, to make space lah for part to make space for the part 2. Okay, so here we go. Okay, here we go, part 2. Now, part 2, hence, okay, which is a very critical keyword, hence, find this expression. Right? So because this kind of question, right, we cannot integrate directly. Okay? Like we haven't learned how to integrate this directly before. So what we need to do, right, is actually to you make use of the differentiation from part 1, making use of the results from part 1 in order to integrate back. So it's really, right, part 1 normally asks us to differentiate first. Then part 2 is to integrate back using it as a reverse process of differentiation. So over here, right, this term over here, if you notice, right, the answer, we just now differentiate this to this answer over here. Can you see that this is the answer? Right? This one over here is the answer, right? Now, so actually what do we need to do is we need to transform this back into the answer over here. So what we have would be, okay, what we have would be like this. Now, in this answer, right, I'm still having a 2, but I don't have a 2 over here. So what I need to do is, now I have this term over here, dx. Now in order to put the 2 here, right, in order to divide by 2, the reverse is I need to multiply by 2 to balance back. Okay, so that I can balance back. So putting the 2 down here, right, to balance back, I need to multiply by 2 on the outside. Okay, now once I get this, right, once I get this form, I can just integrate back to this. Okay, it's just a reverse. Okay, so what I do, it will be just 2, and then it will be just e square root x plus c. Okay, so it's just making use of this answer, okay, then integrate back to the previous question. So it's just like that, 2 square root e root x plus c, where c is a constant. Okay, so that's really it. Okay, so because most of the work has been done in part 1 lah. Okay, so part 2 is actually very easy if you can just spot the pattern. Okay, all right, so that's all for this video on the pop quiz. Hopefully you are able to review some of your mistakes and look into some of the details needed to perform integration smoothly. Okay, so that's all the best. Okay, and happy learning. Okay, bye bye.